Yeah, good evening. We are back with our classes on amines. Last class we studied all about preparation and properties of amines. You should remember how to distinguish between primary, secondary and tertiary alcohol. Which reagent we use? Lucas reagent. Same way to separate between primary, secondary and tertiary amines. We generally use what reagent? Hillsberg reagent, which is called as benzene sulfonyl chloride. We also studied carbyl amine reaction, which is given by both aliphatic and aromatic amines, in which you prepare carbyl amine or isocyanide. We also studied distinction between primary aliphatic amine and primary aromatic amine. What was the test? We generally react primary aliphatic amine with nitrous acid. It forms a disonium salt. The disonium salt is not stable at room temperature as it lacks resonance and hence it forms alcohol. When I react aromatic amine with nitrous acid, I get benzene disonium chloride, which is stable due to resonance and hence it forms what? Disonium salt. So difference between aliphatic primary amine and aromatic primary amine can be done with the help of nitrous acid test. We have studied all reactions of aliphatic amine. Today we will study reactions of aromatic amines. What is the aromatic amine we study? The aromatic amine what we study is what? Aniline. Aniline is also called as what? Formula is NO6H5NH2. So if you look into resonance, you will find this comes here, this forms a bond here, isn't it, in aniline, because it is a conjugate system. So it becomes what species? Electron rich species. So what substitution it gives? Electrophile will come and attack, because electrophile is an electron deficient species. So please write electrophilic substitution in aniline. Aniline shows resonance. Aniline shows resonance and has high electron density at ortho and para position. At ortho and para position. Thus, NH2 group is ortho-para directing group, and it is highly activating group But maybe full resonance complete money. This is how the resonance in aniline takes place. This is the resonance hybrid. The regions of electron high densities are ortho, para and again an ortho. So NH2 group is a highly activating group which a aniline ready for electrophilic attack at ortho, para and ortho positions. Please write resonance in aniline. Okay, now write heading. The first reaction, bromination of aniline. Bromination of aniline. Fine. This is also the test of aniline. Bromination of aniline is also the test of aniline. So, please write. Bromination of aniline is also the test of aniline. Right? When aniline reacts with bromine water at room temperature, it gives a white precipitate of 2,4,6-tribromoaniline. It gives a white precipitate of 2,4,6-tribromoaniline. This reaction is used as a confirmatory test of aniline. This reaction is used as a confirmatory test of aniline. So now let us react our aniline. This is aniline which reacts with bromine water at room temperature, and substitution takes place at all the three places. That is, this is our NH2, this is the second place Br, this is the fourth place Br, and this is the sixth place Br. This is white precipitate of 2,4,6-tribromoaniline. Plus, how many times HBr? From every place I have removed an H and substituted Br. So, 3HBr. Understood? This is the confirmatory test of aniline. So, aniline, when it reacts with bromine water, it forms 2,4,6-tribromoaniline, and this basically is used as a confirmatory test of aniline. Now, the problem is, this is how substituted compound. It is a tri-substituted compound. But suppose I want only orthobromoaniline, or I want only parabromoaniline. In most of the cases we get compounds like that, no? We get when you are substituting an acid, you will get 2-chlorobenzoic acid or 4-chlorobenzoic acid, where para product is the major product and ortho product is the minor product due to electron-electron repulsion. Okay, but here every time NH2 group will react, it will result into what substitution? Tri-substitution. Why? Because NH2 is a highly activating group. So, to bring down the reactivity of NH2 group and to help it monosubstitute, we first do what? Acylation of aniline. First we acylate it. Acylate andre ee place al H remove ಮಾಡಿ ಏನು ಮಾಡ್ಬಿಡ್ತೀನಿ? COCH3 group add ಮಾಡ್ತೀನಿ. So the activity will be reduced and then it will go for what? Mono substitution. So please write. The only problem, this is a 2 marks important question, why aromatic amines are acylated, okay, or how do you bring down the reactivity of aromatic amines. So please write, the only problem with electrophilic substitution the only problem with electrophilic substitution of aromatic amine is their high reactivity. Is their high reactivity as they give tri-substituted products. As they give tri-substituted products. Next point, to get mono-substituted products. To get mono-substituted products, the reactivity of NH2 group has to be reduced. The reactivity of NH2 group has to be reduced, which is done by reacting it with acyl chloride. Acyl chloride formula ಏನು? CH3 COCl. Acyl chloride or acetic anhydride. Acyl chloride or acetic anhydride. Okay? So if we want mono-substituted product from aromatic amine, the first step is to do acylation. So let us react this with CH3COCl. You can even do the reaction with anhydride. So I am taking CH3COCl. The reaction always takes place in presence of pyridine. This I have taught you. What is the reason? Although amine itself is basic, acylation always takes place in presence of pyridine because it absorbs the HCl formed and immediately lets it go in what direction? Forward direction. This was explained even in the last class. So now see, from here one H will be removed and the Cl will be removed. So you will get a compound what? C6H5 NH C double bond O CH3 plus HCl. Can you name this compound? This was taught before. Amines alle ಹೇಳ್ಕೊಟ್ಟಿದ್ದೀನಿ. Common name ಹೇಳಿದ್ದೀನಿ. 2 marks question ಹೇಳಿದ್ದೀನಿ. See, it is a secondary amine. Secondary amide rather. If it was not there, this would have been what? CH3CONH2. CH3CONH2 is what? Ethanamine. Correct? What did I add to ethanamide? Removing it H. C6H5. So what did I add? Phenyl. At which place did I add phenyl? At the nth place. So it is called what? N-phenyl ethanamide or Samiksha, what is it called? I told you, I made you all mark it. Turn madi. See somewhere. Acetanilide, actinolide, yellow head ಕೊಟ್ಟಿರ್ತೀನಿ. ಎಲ್ಲರೂ ಮಾಡಿಸಿದ್ದೀನ ನೋಡಿ. N-phenyl acetanilide, N-phenyl ethanamide, ಆಸಿಡ್ ಅಲ್ಲೂ ಇರ್ಬೋದು, ಚೆಕ್ ಮಾಡಿ. Acids only I think I will have taught. Check ಮಾಡಿ ಬೇಗ. Acids ಅಲ್ಲಿ ನೋಡಿ, reaction of acid with amines. I am not taught. Acids only, no? Acylation of what? Amine. N-phenyl ethanamide. This is also called as what? Acetanilide. Very important. Very important. Done? Now, after doing this, what we will do is, we will brominate it. You can write it in the same line. Brominate it in presence of acid. So it forms what? It forms two products. Either it will be substituted at what position? Ortho position, or will be substituted at what position? Para position. But as the major product is para, we will prefer to write it at para position. So name of the compound, you know? Para-bromoactinolide. Very good. Para-bromoactinolide. Okay, now I don't want this group to be there. I want my aniline back, and I want what? Para-bromoaniline. So what we do? In presence of acidic medium or OH minus, it reacts to form what? Para-bromoaniline. Plus what happens? The acid part is removed, or the acyl part is removed as CH3COOH. Is it clear? Once again I will explain. If I want to reduce the activity of NH2 group and want to go in for mono substitution, I need to react it with acyl chloride or with acetic anhydride in presence of what? Pyridine. I get a compound N-phenyl ethanamide or acetanilide. Pyridine is used in this reaction so that it easily absorbs the HCl form and the reaction proceeds in forward direction, making large number of or the yield of N-phenyl ethanamide increases. Now this compound, when it is brominated, it forms what? Para-bromoacetanilide. When this is hydrolyzed in presence of either acidic or alkaline medium, it gives you what? Para-bromoaniline. It also gives orthobromoaniline, but the orthobromoaniline which is formed is a very minor quantity. So the reaction always proceeds taking the major product. So we have taken the major product and completed our reaction. It should all be written in one line. Okay. Now write next. Nitration. Or before you write, the lone pair of electrons, on nitrogen, of actinolide or acetanilide interact with the oxygen atom due to resonance and hence is less available for donation to the benzene ring. This reduces the reactivity of NH2 group. This reduces the reactivity of the NH2 group. let us write first the logic. You have what? N, it has a lone pair electron. It is then connected to C double bond O, CH3. This oxygen has how many lone pair electrons? 2 lone pair electrons. Now what happens? This comes here and this goes here due to resonance. So as a result of it, what you get here is, as N has lost its electrons, it becomes what charge? Positively charged. The electrons will form what bond? Double bond, C, single bond, O. How many lone pair electrons now? 3 lone pair electrons and a negative charge and CH3. So the moment you acylate, the lone pair electron which was on nitrogen now goes to oxygen and is not available for donation to benzene ring for resonance. As a result of it, the electrophilic attack on the benzene ring reduces and hence only what substitution takes place? Mono substitution takes place. Please write this. What I said is, generally NH2 group has a lone pair electron on nitrogen atom which is highly activating and goes for tri-substitution. If I want to reduce the activity of NH2 group, I should acylate the NH2 group either with acetic anhydride or with acyl chloride. If I do that, the lone pair electron which is present on the nitrogen atom goes back to the oxygen due to what? Resonance. So it reduces the activity or the reactivity of the NH2 group and makes it only fit for what substitution? Mono substitution. Right now, next reaction, nitration. Please write the next reaction, nitration. Direct nitration of aniline. Direct nitration of aniline yields Terry oxidation products. Terry oxidation product means thick oil based oxidation product. Terry oxidation products in addition to nitro derivatives. Please write aniline, then it is nitrated. Aniline nitration is always done in presence of what? Nitrating mixture. What is nitrating mixture? Concentrated HNO3 and concentrated H2SO4. So this aniline, when it reacts with concentrated HNO3 and concentrated H2SO4, it forms what? First, orthonitroaniline, metanitroaniline and paranitroaniline. It forms what? Orthonitroaniline, paranitroaniline and metanitroaniline. So let us write percentages. This is 51%, this is 2% and this is 47%. Okay? What is so abnormal about this? What is so abnormal about the reaction? We have always studied that all or most of the groups are what groups? Ortho and para-directing group. We never get what? Meta-directing group. So a 2-mark question which generally comes here is, although NH2 group is ortho and para-directing group, then how come during nitration we get what aniline? Meta-nitroaniline. First write the equation, write orthonitroaniline, meta-nitroaniline, para-nitroaniline. Please write. Written? Percentage birthday? Now write. Very, very important question. You can put as many stars as you want and write. Although NH2 group is ortho-para-directing group, then why is meta-nitroaniline formed? Then why is meta-nitroaniline formed on nitration of aniline? Why is meta-nitroaniline formed on nitration of aniline? Fine. Can you think of some reason? Can you think of some reason that why it forms meta-derivative?
Long para.
See, what happens is when there is a very strong acidic medium, okay, a part of aniline gets protonated and forms what ion? Anilinium ion, NH3 plus. As it is a very strong acidic medium, a part of aniline gets converted to what? Gets protonated and gets converted to what ion? Anilinium ion. And that anilinium ion is what directing? Meta-directing. So we say the major chunk of aniline gets converted to para-nitroaniline. But during nitration, as it is a highly acidic medium produced, proton comes off and it forms what? C6H5NH3 plus, which is called as what ion? Anilinium ion. And this anilinium ion is what directing? Meta-directing. So we also get what? Meta-nitroaniline. Please write your answer. In strongly acidic medium, aniline gets protonated to form anilinium ion. To form anilinium ion. To form anilinium ion, which is meta-directing group. Hence, along with ortho and para-nitroaniline, meta-nitroaniline is also obtained. Meta-nitroaniline is also obtained. Please write C6H5NH2 plus H plus in presence of concentrated HNO3 and concentrated H2SO4. It forms what? C6H5NH3 plus. This is called what ion? Anilinium ion. Is it clear? So this is a very typical reaction. So most of the time this reaction is asked, because generally you will always write what? Orthonitroaniline and para-nitroaniline. But whenever nitration of aniline is done, you also get quite a large chunk of meta-nitroaniline. This is because in acidic medium, aniline gets protonated to form what ion? Anilinium ion. Now write, to get monosubstituted nitro compound, what will be done first? Acylation is done first. And then nitration to get para-nitro derivative as the major product. Please do the reaction yourself and I'm going to pause the video. React ಮಾಡಿ ಆ ಹಳೆ reaction COCH3 plus and NO2 group here. So now when I hydrolyze it in presence of H plus or OH minus, I get what? NH2 and NO2 plus what I get? CH3 COOH. This is what compound? Para-nitroaniline or 4-nitroaniline. Those of you who have not written it correctly, kindly check once. Okay? This is a very important step only to get what products? Monosubstituted product. So summing up for nitration, what we have? Nitration of aniline gives a wide variety of products. You get orthonitroaniline, para-nitroaniline as well as meta-nitroaniline. Although NH2 is ortho-para-directing group, why does it form meta-nitro compound? Because when it is concentrated, when it is highly acidic medium, aniline gets protonated to form what ion? Anilinium ion. And this anilinium ion is what directing? Meta-directing. If I want to get only monosubstituted product, I react it with acyl chloride. I get N-phenyl ethanamide, which when treated with concentrated H2SO4 and HNO3 forms para-bromoactinolide, and which on hydrolysis will give you what? Para-nitroaniline. Clear? Alright, next heading, sulfonation. Please write sulfonation. Aniline reacts with concentrated H2SO4. Aniline reacts with concentrated H2SO4 to form anilinium hydrogen sulfate which on heating at 453 to 473 Kelvin produces para-aminobenzene sulfonic acid. I am writing it here, para-aminobenzene sulfonic acid, which is also called as sulfanilic, acid, which exists as Zwitter ion, कुछ याद आ रहा है? Zwitter ion, somewhere you read? Where you read? Biomolecule. Biomolecules, which part? Amino acids. Amino acids always exist in the form of what? Zwitter ion. What is isoelectric point? So beautifully read. What is isoelectric point? When amino acids neither move towards the cathode nor move towards the anode, it is called as what point? Isoelectric point. Okay. So this time let me easen out. This week I will not keep test. The reason being, you all have to write math test. So read math well. Anyhow, I have seen your papers beautifully with single digit to double digit to everything. So write your maths and let sir also get the feel of writing. You both can also write. Okay, on 2nd October it is, if you want. Okay, so Nritya, so please write which exists as Zwitter ion. I will explain Zwitter ion. Okay, write the equation. First thing, C6H5NH2. This reacts with what? Concentrated H2SO4 to form what? Anilinium hydrogen sulfate. So it forms NH3, 1H gets added up, so it becomes what? NH3 plus. What is left? 1H got protonated, it becomes NH3 plus. What is left? HSO4 minus NH3 plus HSO4 minus. This is called as what? Anilinium hydrogen sulfate. Kelgade bariri. Which when heated to 453 to 473 Kelvin forms now the naming will change. Now NH2 group is not the main group. Now which is the main group? SO3H, because according to priority table, SO3H takes first priority. So 1, 2, 3, 4. So this can be called as what? 4-amino benzene sulfonic acid, or it is also called as what? Para-amino benzene sulfonic acid. This is also called as what? Sulfanilic acid. This is Zwitter ion ಮಾಡ್ತೀರಾ? ಗೊತ್ತಾ Zwitter ion ಏನು? Zwitter ion is movement of H plus here. So it will become what? C6H5 NH3 plus and SO3 minus. Is it clear what I have done? Aniline in presence of concentrated H2SO4 gets protonated and adds up the whole thing. This is called as what? Anilinium hydrogen sulfate. This, when it is treated at 453 to 473 Kelvin, it forms what? 4-amino benzene sulfonic acid or para-amino benzene sulfonic acid. How does it exist? It exists as what ion? Zwitter ion. Clear? See, we study hardly 3 reactions of aniline, and all 3 reactions of aromatic amines are important. First is bromination, where it gives 2,4,6-tribromoaniline, which is a white precipitate. It is a confirmatory test of aniline. If I want to reduce the reactivity, I need to acylate it and get into N-phenyl ethanamide, which will finally give me para-bromoaniline or 4-bromoaniline. So one part clear, confirmatory test of aniline, reacted with bromine gives 2,4,6-tribromoaniline. Second part, which comes with nitration. Although NH2 is ortho and para-directing group, but still it gives you what product? Meta-nitroaniline. Why? This is because during nitration, a very strong acidic medium is created. The aniline gets protonated to form what ion? Anilinium ion. And this anilinium ion is what directing? Meta directing. So along with ortho and para-nitroaniline, even metanitroaniline is also formed. Second important reaction. Now third, sulfonation. When you sulfonate, generally SO3H group gets added, isn't it? So we say sulfonic group gets added. But in aniline, it first gets protonated and completely adds up to form anilinium hydrogen sulfate and then forms benzene sulfonic acid. This aminobenzene sulfonic acid is called sulfanilic acid and it exists in the form of what ion? Zwitter ion. Next, most of the time, what reaction we study? Friedel-Crafts. So now, very important, please write, aniline does not show Friedel-Crafts alkylation or acylation. It does not show Friedel-Crafts alkylation or Friedel-Crafts acylation reaction because aniline is a Lewis base. Because aniline is a Lewis base or Lewis base as you say, and Friedel-Crafts reagent Any Friedel-Crafts reagent? Anhydrous AlCl3. Is a Lewis acid. Anhydrous AlCl3 is a Lewis acid. Hing acid ಹೇಗೆ ಕೊಡ್ತೀವಿ? ಇದು aniline ಯಾಕೆ Lewis base ಇದೆ? Because it has the presence of lone pair electron on the nitrogen atom. So all lone pair electron or electron rich species are called as what bases? Lewis bases. Now let us talk about AlCl3. You know Al has got how many electrons in its outermost orbit? 3. If it reacts with 3Cl, how many electrons it has got in its outermost shell? 6. It is an electron deficient species because how much it should be? 8. Chemical bonding will go with 3. Electron rich, electron deficient, odd electron pair. So same way, this is an electron deficient compound. So it behaves as what? Lewis acid. Electron rich behaves as what? Lewis base. So rather than aniline reacting with acyl chloride or with alkyl halide, aniline will first react with the reagent which is AlCl3 to form a salt. So the reaction will not take place. Clear? Please write. Because aniline is a Lewis base and Friedel-Crafts reagent anhydrous AlCl3 is a Lewis acid. It reacts with AlCl3 to form salt. Please write the reactions. C6H5NH2, C6H5NH2 plus AlCl3, it forms C6H5NH2 plus and AlCl3 minus C6H5NH2 plus and AlCl3 minus. This is what? It is a salt. Due to the positive charge on nitrogen atom, electrophilic substitution in the benzene ring, is deactivated. Hence, aniline does not give Friedel-Crafts alkylation. Fiddlecraft alkylation or acylation. Fiddlecraft acylation or alkylation. Okay, so this is all about aniline. Now we are left with what? Basicity of amine. Heading Barili, basicity of amines. Okay, now regarding your syllabus which is left out here, we have something called as diazonium salt which has been removed from your syllabus because NCERT has removed it. Even NTA which conducts JEE exams, 2 days before only the circular has come that even NTA will follow whatever is the reduced syllabus of CBSE board, because your JEE I think happens to be in January or maximum by Feb. Okay, if it is postponed. So as a result of it, even in that it will not come. But your NTA does not conduct NEET. So NEET may not reduce this portion. So for all people who are going to write NEET, you will have to come extra and study from NEET. Otherwise, because till now it was not a clarity that whether NTA will agree or not, but NTA has given a clear-cut logic and CBSE has also told that no reduced syllabus will be asked. So you don't have to study, but although if you finish the chapter, or I will make sure that I send the notes of that particular part if you want to read through it. Out of that, only 2 reactions are important, that is Gattermann's reactions and coupling reaction. So diazotization is not there in your syllabus because it is very difficult for all of you to read so much. Anyhow, there are a lot of organic reactions. So as we studied the acidity of carboxylic acid, one pakka question comes on basicity of amines. So write heading, basicity of amines. We all know amines are what in nature? They are basic in nature. So please write, amines being basic in nature, amines being basic in nature react with acids to form salts. React with acids to form salt. So let us write a general reaction where we are taking both amines, aliphatic as well as aromatics. So first with aliphatic amines, I write an amine as RNH2, primary amine, I react it with an acid. So it forms salt. How? This gets protonated. So it forms what? RNH3 plus what minus? X minus. Correct. Correct? If I take aniline, C6H5, NH2, and I react it with HCl, it forms what? C6H5, it gets protonated again, NH3 plus Cl minus. This is called as what? Anilinium chloride. Anilinium chloride. Please write, amine salts on treatment with a base, amine salts on treatment with a base regenerate the parent amine. Regenerate the parent amine. That means if I take R NH3 plus X minus and I react it with OH minus, which is what medium? With a basic medium, I get back what? RNH2 plus H2O plus X minus. Artha mole reaction. First thing, when any aliphatic amine reacts with acid, it forms a salt. Salt has a positive ion and a negative ion. When an aromatic amine reacts with acid, it also forms a salt. This shows what? Amines are what in nature? Basic in nature. From the salt, I can retrieve back my parent amine by reacting in what medium? By reacting it with the base or by reacting in basic medium. Please write this equation. Right after that, the reaction of amines with mineral acids to form ammonium salts shows that amines are basic in nature. Next point, they behave as Lewis bases. They behave as Lewis bases due to the presence of lone pair of electron on the nitrogen atom. Lone pair of electron on the nitrogen atom. So this is a 2-mark answer to prove that amines are what in nature? Basic in nature. Amines are basic in nature because they react with acid to form salts. These salts can retrieve back the original amine when you react it in what medium? Basic medium. Fine? But we also know that if I have given a value, Kb value or pKb value kotre, how do I find out basicity of amines? So write next. Basic character of amine. Basic character of amine or amines can be explained in terms of Kb and pKb values. Kb and pKb values. Kb and pKb values. What is Kb? What is Kb? What is K? Dissociation constant. This is what Kb is. Dissociation constant of a weak base. What is Ka? Dissociation constant of a weak acid. Because for strong acid and strong bases, dissociation constant is always equal to 1. Now please write RNH2 plus H2O will give what? It will be protonated. It will give what? RNH3 positive plus OH minus. Fine? Now to this I can apply equilibrium constant. So what is K equal to? Concentration of RNH3 plus concentration of OH minus by concentration of RNH2 and concentration of water. Is right. Right? When water is taken in large excess, this is taken as 1. Concentration of H2O will be taken as what? 1. Okay. So what we will write? Kb now becomes what? RNH3 plus OH minus by RNH2. This is Kb value. Larger the value of Kb, or more is the value of Kb, stronger is the base. More the value of Kb, stronger is the base. Now write pKb is equal to minus log Kb. pKb is equal to negative log Kb. What does it mean? Larger the value of Kb, smaller the value of pKb. Sorry, larger the value of Kb, smaller the value of pKb, and stronger is the base. Some table will be given. Please take out table 13.3 in the textbook. Very, very important for your competitive exams. See the Kb and pKb value and write which is a stronger base. 1, 2, 3, 4 anta bariri. Pause mado idana. Textbook tegiri that table. Table 13.3 highly important, and please remember the table's heading. The table's heading states pKb values of amine in aqueous state. In gaseous state it is different, in aqueous state it is different. So first we will talk about aqueous state. In that table please write pKb value of ammonia is 4.75. So you find out that the value of amines which are aliphatic amines are less. So first question please write why are or which is more stronger, alkyl amine or ammonia? Which is more stronger, alkyl amines or ammonia? Now question answer format al barspadta idini so that you know how much to write for your exams. Okay, please write alkyl amines are more stronger base than ammonia because alkyl amines have an alkyl group which shows which effect?
Positive effect.
Good, which shows plus I effect or electron releasing effect. This group increases the electron density. This group increases the electron density over nitrogen atom and hence makes the lone pair of nitrogen easily available for donation. Okay, now let us write our reaction or to show how it shows plus I effect. So first thing we will write R, N, H, H, and this is our lone pair electron. When it actually has to what? It has to react with H plus because the proton has to come and react. So what it does? This will release the electron towards the nitrogen atom as it is what? An electron releasing group. So the electron density over this nitrogen atom increases and it very easily forms what? R, N, H, H and one positive sign. Salt बनाता है, ठीक है? But in case of ammonia, which is NH3, there is no alkyl group or there is no electron releasing group. So when it reacts with H plus, the reaction is slow and it forms what? NH4 plus. Is it clear? Why are alkyl amines more stronger than ammonia? Because of the presence of what group? Alkyl group, which releases all the electron towards the nitrogen atom, as it shows what effect? Plus I effect. So the electron density over nitrogen atom is increased and it is easily available for donation or reaction or reacting it with protons. Clear? Next point, Barili. The pKb value of ammonia, the pKb value of ammonia is 4.75, while that of aliphatic amine, right, methenamine is 3.38, which justifies that alkyl amines are more basic than ammonia. Alkyl amines are more basic than ammonia. Is the answer clear? All of you, is it clear? Plus I effect. Now write the next question. Which is stronger, aniline or ammonia? Or which is more basic? Which is more basic? Aryl amines or ammonia? Aryl amines or ammonia? Which is more basic? Ammonia. Why? Because in aniline, the electron which is present over the lone pair electron goes towards the benzene ring and is not always present on the nitrogen for donation. Whereas in ammonia, there is no delocalization of electron and the nitrogen is always available over the lone pair electron is always available over the nitrogen atom for donation. Please write. Aniline is less basic than ammonia because the phenyl group of aniline exerts minus I effect and due to resonance there is lower availability of electron on the nitrogen atom for protonation. Correct? You can write even this, or you can write that the NH2 group basically sends the electron towards, there is delocalization of electron due to resonance and there is not availability of lone pair electron for protonation. Okay, write second point. In aniline, the NH2 group is directly attached to the benzene ring forming a conjugate system due to which the lone pair electron is not available for protonation. You have to leave space to draw all the resonating structure of aniline, okay, and then write one solpa jaga bedi resonance in aniline ke, and then bari. Whereas in ammonia, there is absence of resonance and the lone pair electrons are easily available for donation. And the lone pair electrons are easily available for donation. Is it clear? So now today we will stop here. Tomorrow get your first book. Also, this is not complete. We still have differentiation between primary, secondary and tertiary amine, or order of basicity of primary, secondary and tertiary amine in aqueous phase and gaseous phase. After that it finishes, and I will start with coordination chemistry. It is a very important chapter. It is a new chapter for you. Just as you studied naming of organic chemistry, naming of coordination compounds is also very, very important. Make sure not to miss classes. Because if you miss, then understanding it in the next day becomes very, very difficult, as it is completely a new concept. So half an hour we will do surface chemistry, because surface chemistry you have to read, like we read 10th May environment and all. So half an hour I will do surface chemistry, 1 hour I will do coordination chemistry. So get your first book, and for coordination chemistry get a new book if possible. Okay, so that if we have to revise questions on organic chemistry and do conversions on organic chemistry, the same book can be used. Okay? Even for your JEE, polymers and all will not come, because whatever is a reduced syllabus will not be asked. So don't concentrate much on polymers, chemistry in everyday life, because in JEE 2 questions or 1 question on polymers was must. But now this year, as they have reduced, they may not give. Okay? Thank you.